Alright guys, today what we're going to do is just do a little recap on multiplying polynomials. Alright, now normally you would like to use is the box method. That is a good tool. However, if you don't know how to use it properly, it's more of a memorization tool, and if you don't know what to do, then you're stuck. I'm going to show you a different way, and you can choose either way you want, but it's called the distributive property, or using the distributive property to do this, and it helps you if you're unsure. You can reason it out and then still get the right answer even without using the box. Let me show you what I'm talking about when I'm talking about the distributive method. I'm going to do something very simple first. Let's say we have 3x times 3x squared minus 4. Right? What would you do? Right? Distributive method says you would take this 3x, right, and you would multiply it to the 3x squared, but also to this minus 4. So the simplified answer would be, well, 3 times 3 is 9. X times x squared is x cubed. 3x times a negative, or minus 4, would be a minus. 3 times 4 is 12. No x to multiply over here, so you just leave it at the end. That is it. That's the distributive method. Y'all know how to do that. But what if, instead of this being a monomial, it's a binomial? In other words, 2 terms times 2 terms. You would want to do the box. Let me show you how you can do it using this distributive method. And then I'll also show you how to do it with the box. You'll get the same answer. Alright guys, let's take this distributive property to the next level. A polynomial times a polynomial. We'll make it easy, and we'll just do a binomial times a binomial. Right? Let's say we have 2x minus, no, I say plus 5 times 3x plus 1. Alright, multiply these together. Right? First thing, people want to do box. Fine, but that's just a tool, a memorization tool. It's still systematic. You can still get the right answer, but let me show you why the box method works. It's because of the distributive property that we're about to use here. I'm going to take this 2x, just the first term, and I'm going to distribute it to the 3x, and then I'm going to also distribute it to the plus 1. Alright? We're going to multiply those together, and let's see what we get. Alright? We get 2x times 3x. That is, I'm not going to use a different color, I'm going to use black. 2x times 3x is 6x squared. 2x times 1 is a positive, or plus 2x. Now the other thing we got, alright, is this plus 5. That has to be distributed as well. This positive 5 is going to go to the, right there, to the 3x, and to the plus 1. Alright? Just like the 2x was distributed to the 3x and the plus 1, the 5 also has to be distributed. Alright? So 5 times 3x, hey, that's 15x. What's 5 times 1? 5. Just like in the box method, you have 2 terms that you have to combine that are alike. These guys right here, the ones with just x's. You got a positive 2x and a positive 15x. So what do you get when you simplify this out together? There's no other x squared, so it's going to be 6x squared. 2x plus 15x, that's a positive 17x. Alright? And then on this lonely 5, just like this 6x squared doesn't have anything else with it, just leave it at the end. Alright? The only things we had to combine were those like terms right there. And that is your answer. You could do this with the box method. Alright? A lot of people would want to do it this way. Alright? You got a box. It's a binomial times a binomial, so 2 by 2. Alright? You're going to put 2x here, plus 5. Then you got a 3x, plus 1. I'm doing this fast because we know how to do this. Alright? And let's see, 2x times 3x, 6x squared. 2x times 1, 2x. 3x times 5, 15x. 5 times 1 is 5. What do you notice? Same two numbers, same two terms. 2x and 15x. You're going to have to combine them. You got 6x squared plus 17x plus 5. Same thing. You get the same answer. But the distributive property works also just like the box method, alright, with bigger terms. What if you had a trinomial times a trinomial? 3 by 3 box, or you would have to distribute 3 terms. Okay? Gets a little tricky here, but it's the same thing. Alright? I wanted to show you this because it's a very helpful tool, especially if you forget what to do here. Just do the distributive property. Distribute the first term, distribute the second term. If you had a third term, distribute that again. Combine like terms, you got your answer. There we go. Now let's talk about factoring. Right? We're only going to factor quadratics, right? When we have to use the box. Okay. Now you could factor by factoring out maybe just a single monomial or a single term out. But what I'm looking for here is the box. Okay. A lot of people like to use the box when you do quadratics. Right? If it's anything bigger than a quadratic, like a cubic or quartic, we'll use division, okay, and that's later on. Right? But for factoring, I'm going to do the box first because that's what we're more comfortable with, and then I'm going to show you another method. It's kind of a guess and check, but it's still kind of systematic, kind of like the box, all right? And you can see how they're related. Let's do the box first. All right. It's a quadratic, so it's 2 by 2. You always put the first term in this box. You put the last term with its sign here, right? And then we got to look for a sum and a product. The sum always comes from the middle term, all right? And negative 7x. The product comes from the cross product between these two. So negative 6 times 3x squared, negative 18x squared. You got to figure out what goes in these boxes, okay? You need to find 2 terms that when you multiply together will give you negative 18x squared, but will add to a negative 7x. Well, let's just think about this here. We know both terms are going to have an x, because when you add them together, they have to have an x. When you multiply them together, they're going to have an x squared. So let's just concentrate on the terms here. What 2 terms, what 2 numbers, I should say, when you multiply together, you get a negative 18, right? Well, the just 18, you think of 2 and 9, right? Or 3 and 6. But let's think of 2 and 9. Well, that'd be a positive 18. We want a negative 18. One of those terms, one of those numbers needs to be negative. It's either a negative 2 times 9 or a negative 9 times 2. Well, I'm looking at this guy. This is going to determine which one's negative and which one's positive. Well, if I had a negative 9 and a positive 2, you multiply those together, you will get that negative 18x squared. Also, if you add a negative 9x plus a 2x, that's a negative 7x. We got the right factors here, okay? All right, for this product, and we got the right right numbers to get this sum. Now we gotta factor stuff out, okay? What did this have in common? Only has an x. This has a negative, looks like just a 3. This has a 3x in common. And then this has a just 2 in common, positive 2. So our answer for this one, right, using the box method, we're factoring this guy, the factored version of this, ends up being, I just like to use the top first. It doesn't matter which factor you choose first, always put the top first. X minus 3, 3x plus 2. That is the factored version of this polynomial. Alright? Now I'm about to show you how to do the same thing, alright, using the, comparing it to the box method, but doing it a different way. Okay? Okay, we're going to factor now the same polynomial, alright, but in a different way. Look real quick. Look at your factors here. What do you notice? These leading terms for each factor, x and 3x, what happens when you multiply them together? You get 3x squared. What happens when you multiply a negative 3, these in terms, the negative 3 and the positive 2, negative 6. So, I already know the answer, but let's reason it out a different way. Okay? Okay. 3. What are the only factors of 3? 3 and 1. So there's going to be a 3x here and 1x here. Multiply this together, you get 3x squared. Okay, how do you get 6? Now this one is a little tricky. You could say a negative 1 and a positive 6. You could say a positive 1 and a negative 6. Negative 2, positive 3. Negative 3, positive 2. Alright? This is where it's guess and check. You're going to have to play around with this. That's why people like this better, because it's just very systematic. If you got that down, then do it. Alright? But this is what I would always say. Alright? Well, I know my goal here is to be a negative 7x. Okay? When I add some terms together. Alright? Well, let's see here. I could say, what if I did a negative 2 and a positive 3? Obviously that's not the right answer, okay? But what happens? Well, 3 times negative 2 is negative 6, so it seems like it works. But what determines the right answer is what happens when I multiply 3 times the x, okay, and the 3x times the negative 2, okay? That's a negative 6. What happens when you add those together? That's a negative 3x. That is not negative 7x. So that cannot be right. Let's change the signs. Okay? Let's say it's a positive. Well, let's just change it on. Let's just say negative 2 and positive 3. Will that work? Alright, see, it's a guess and check. Alright, negative 2 times 3, negative 6. So far, so good. Well, what happens when you multiply 3x times plus 3? That's a 9x. Okay, what about a negative 2 and x? That's almost right. I got a 7x, but I need a negative 7x. So I'm close. What's the only thing I should have done? Change the signs. Still get a negative 6 when you multiply them together. Now this becomes a negative 9x. 2 times x is a positive x. Now when you add them together, positive 2x. When you add them together, negative 9x plus 2x, that's a negative 7x. That is what we need. So, we just found the answer. Choose your method. Does not matter. Alright? I think you just need to be exposed to other methods than just the box, because the box works systematically. It's a good tool, but sometimes, like, this is more involved, so you probably would want to do a box, but simple factoring, you don't need to use the box, especially when you don't have a leading coefficient other than 1. If it's a 1 in front, you don't need to use the box. You could do it this way and you can get it really quickly, right? So, that is my little spiel about multiplying using the distributive property in the box, and then factoring using the box and, I guess, a check method. Alright, hope that helps.